So hi everyone, welcome to today's lecture, and we would basically continue from where we stopped yesterday. Yesterday we started writing a simple smart contract, and the contract had to do with a library. So it was just a simple library implementation contract, and this implementation contract has certain functionality that listed. So sharing my screen now. We have all of these functionalities we listed that we wanted our smart contracts to include. We also started by ensuring that the aim of this smart contract we are building is for us to understand how to store data, how to get data, how to construct data type, and the business logic, basically. And so that is exactly what we have been doing from yesterday's class, and we'll basically continue from where we stopped. So we were able to create a trait for all of these functions that we created. And this trait includes the initializer, add book, remove book, find book, list book, and even count books. Now, we've been able to implement the function initialize that creates the library key and also sets in the library key the data structure that is meant to be there. And from what we have here, the data structure that is meant to be a structure of library with a field element book that has a vec of struct book. And that's basically what the data structure looks like. Now, moving on, we continue to this class by implementing the remove book. So the remove book literally is a function where we would be able to remove a book from the library. So imagine we add a book to the library. We should also be able to what? To remove a book from the library, or we could even call it borrow. Instead of remove, we could change it to borrow book. So first, let's remove this to do macro. And to do that, basically, we need to get the library. We need to get the instance of the library as usual. I mean, that's usually the first thing we do, to get the instance of the library. So to get the instance of the library, we can create a variable, and we can make it a mutable variable because at the end of the day, we would basically still be doing what? We would basically still mutate the storage. So we'll do env.storage dot instance. So we want to get the instance, and then we do dot get. So what we want to do is basically we want to pass in the library key, and then we want to unwrap, but we would not just be unwrapping. We would use unwrap or else. And then what then would be in the else? We literally create a new library. Create a new library, and inside of it, we create an empty vec, vec new, and then we pass in the env inside of it. So now we've created these. Let's use cargo fmt to format. Good. So we've created these. The next thing we want to do, obviously, would be to now modify this book. So first of all, we want to modify the book, the library. And to modify the library, the functionality is basically to remove a particular book from the library. So how do we get the book we are trying to remove from the library? First of all, since this is a vector, we can get the index of the book. So we can first of all get the index of the book. And to get the index of the book, we would basically have to use the title of the book to get the what? The index of the book. So we say let index equals what? Library dot what? Dot books. Then we would iterate through it. We use the iter function. We iterate through it. Then we will get the position, dot position. And how do we get the position? We are basically going to use a closure. We pass the book in, use a closure, and then we say book dot what? Dot title. So if the book title is equal to the title we passed in from here, then at that particular point, we get the index. So with this, we've been able to literally get the what? The index of the book. So it's returning to us an option use size. So let's destructure this option use size. And to do that, we can basically use the if let. So we say if let sum, and then we pass in, let's call it I. That's the index. And we say the index, and basically for the index, we want to get it by removing the book. So that means we want to remove index I from this particular vector. So we are looking to remove index I from this vector. So that's what we're about to do. So to do that, we then say library dot books dot remove. And then we remove what? Remove the index I. And in that case, we've been able to successfully remove the book. So in this particular case, index is returning a U size. So this is an option U size. So if we destructure it, this I is meant to give us a U size, as you can see it here. But then to convert it to something we can actually use as index, we need to do as what? As U32. And that will convert I to what? To an index. So what's the next thing we need to do? The next thing we need to do is to set the storage back. So we are going to set the storage back since we have already what? We've already modified the storage. We're going to set it back now. And to do that, we use the library key. And then the value in this case would then be what? Would be the library. And we are literally good to go. We have automatically completed what? This remove function. Now, the next function we have to do is find book. But before we move to find book, are there any questions on this remove function? Anything anyone doesn't understand from the remove function? Any question? Can use the raise hand button if you have any questions for the remove function. Okay, so there are no questions. Having that at the back of our mind that there are no questions, for the find book, we would implement the find book. So what is the find book doing? The find book is literally allowing us to find a particular book. And when we find that particular book, we can return the whole data about the book. So we are going to find the book by the title. I think we in fact specified it here that we want to find the book by the title. So as usual, we are going to create the library to get what is in it. We are going to use library because we want to get the library. And as the same thing, env.storage.instance, we want to get the storage. We also want to get the instance. And then we want to do dot get. And then we get the library key and we unwrap. And remember I said I don't like us using unwrap, so we use what? Unwrap or else. And then for this, you can use library. You create a new one. Library. And we have books. So you can basically do this. So after doing that, The next thing we want to do is we want to look for the book, and we want to look for the book with the title. So to do that, we are just going to basically iterate through the vector. So we are going to say the library dot the books dot what dot into iter. So we are going to use into iter. Then we are now going to use dot find. So dot find, we are going to pass in the book title we are trying to find. So we're going to pass it in, create a closure. Inside of the closure, we write book, and then we want to find the book. So we're going to say book dot title equals what? Title. So whatever book is equal to this title, we want you to what? To return it. How do we know that this is going to return an option of book? So if we even save this one inside of a variable, let the book, we can name it the book. Let's name it the book equals this. And we see if we put this here, we can then return what? We can say return the book. So this basically still works. And this shows that it is actually return what? Is returning an option of book. But this is long journey. There's really no need for us to do all of this stress, just for us to return the book. And so doing this, we have officially implemented what? The find book. The one on the next for us to do is the list book. Using this, we want to list all the books inside of the library. And to do this, we are just basically going to return the book. We return the instance of the library. We say library. Notice that, in fact, we have repeated so many things. So many things. And it just feels like the smart contract is really, really easy. And to be very honest, it is actually very easy. Although one of the reasons why it looks like this is because the implementation we are working with is not such a difficult implementation. And that's why it's like this. So we pass in the library key, then we do dot unwrap or else, dot unwrap or else. Then we create an anonymous function here. And we create the library for this. Then we close it with this. And then the next thing we do is literally to return the books, to return all the books in the library. So we're going to say library.books. And this is literally going to return to us all the entire book inside of the what? Inside of the library. Notice that I did not use mute keyword here. Why? Because I'm not trying to mutate the storage. I'm only trying to get from the storage. The same thing happened here. But because I'm trying to mutate the storage, that is exactly why I use the mute keyword here. Because I'm trying to what? Mutate the storage. And the last thing we want to do is to count the books. So to count the books, all we have to do is literally the same thing, but this time we are going to use the dot length function. We first of all want to get the book, so I'm just going to copy this and paste it here. And then I think we missed this. And then the next thing we want to do is then to do what? Library dot books dot length. Now, if you do dot length, what it returns is what? Is a U size. But in this case, what we expect it to be is a U32. So you can use it as what? As U32. So that's it. So you doing this, Looking at our implementation, we have officially completed everything we wanted to do. We've been able to implement add book. We've been able to implement remove book. We've been able to implement find book, implement list book, and count book. So this is literally the implementation. This is the smart contract for what we want to implement. And we're officially done with this smart contract. Unless something, we have to write a test for it. So how do we write the test? So before we proceed to writing the test for it, are there any questions at this point for anyone that wants to ask any question? You can go ahead to ask questions if you have any question. Okay, since there are no questions, we will then be moving on to implementing the test. Let's go back to our code. Let's now, okay, someone has a question, I guess. Oh, Mark says he raised his hand. Okay. Can you bring Mark to the stage so we can hear him speak? Said he raised his hand. ID, please, could you unmute Mike? Could you bring him to the stage so we can hear him?
Thank you.
Yeah.
Hello, can you hear me?
Yeah, I can hear you.
Okay, Mr. Ayo, I was just curious if you could bring us back to the initialize code, because I'm following up with how you're running, and there must be something that I'm doing wrong. So I wanted to just double check and compare in just a moment.
Yeah.
Okay. Right. Just a second. Yes. Uh, 1 second. I'm just gonna take a photo of this and then we can proceed. So I don't.
So that means you'd have to try. Okay. So now let's start with implementing the test. Now for the test, we notice that there are certain things we used here, like vec. Okay, we've imported the vec here. What else do we need? We need the env. Then we also used this symbol shots. Sorry, please give me a second. Sorry for that. So the next one here, we need to add the symbol shot and import it because we basically used it. And so we have to, also import that there. Then the next thing we want to do is basically to test the function initialize. I mean, we have to initialize. So let's test it. Let's name this test initialize. Okay. So for this test initialize, what do we want to do? First of all, we want to create the environment. We want to mimic the environment by creating it, and here we have it as the default. And yeah, then the next thing we want to do basically is to create the contract ID. And the contract ID is just basically to register the contract. So we use env.register for that. And then we're going to pass in, okay, register. We will use register contract. And for that, we're going to pass in none for the contract ID, and then we would also pass the name of the contract. What's the name of this contract in our case? It's library contract. We're going to pass library contract here, and we're going to close this. Now, there's a reason why I am using this register contract. If you notice it, we have like a cross on this. This means that this has actually been deprecated. So if you look at it, it says use of deprecated method. So it's asking us to use register instead of register contract, because register contract is what we used to use before. Now it's deprecated. And that's what I made mention from previous classes, that yeah, you just have to keep moving with the system. Some things could go out of play and they would become obsolete. So let's change this to register. So now register is a new method. And for this, it says register is not satisfying the following other types implementation trait requires. So it's requiring us to do this. So let me remove this and let's see what register asks us to do. Inside of register, it just wants us to what? Pass in the what? The contract and what? The constructor argument. Right? So we'll come back here and we'll pass in the contract. What's the contract? That's the library contract here. And then we can pass in the argument. For now, we would use none. Okay. Why is it not accepting none? Let's go back to it and check. What does it accept? So contract takes in the ID as none and the constructor argument. Okay. Wow, they changed this. Register as. So the constructor argument, they're asking it to be a generic. In this case, I really do not want to pass. I really don't have anything I want to pass in here for it. So let's think of something. If we use 0 for it, would we still have a problem? Yes. It says it doesn't satisfy these traits, the following traits. Okay, so if we do this, what happens? Yeah, so it satisfies it now. So here's the thing. Um, you basically would always have an upgrade. You basically would always have an upgrade. Earlier, it used to be register contract. Now it is register. So that's the thing about programming. There is always upgrade. There is always upgrade. I'm sure I had this upgrade when I updated my Stellar CLI, because what I used before was register contract. And as you can see, it is now deprecated. As you can see, it's now deprecated. Let's go into it. So it takes in the contract ID and the contract itself. So this used to be what we used to use before, but now it's deprecated. So let's just use what we have now. And so when we have this, we now have the contract ID. The next thing we want to do is to create the clients that we would use to interact with the contract. So let's just hope this, what we use is not outdated. So we're going to use contract library client new, and we're going to use um, env, and then passing the contract ID that we created. So this contract ID. And then yeah, with this, we now basically have all the methods inside of this particular contract. We now have all the methods inside of what? Inside this contract, basically. So the next thing we want to do is basically to check for this particular contract. Check for this particular contract. So we are going to use client.initialize to initialize the contract. And so that means we've been able to successfully initialize this contract by calling that. And then we can check for this initialize. We can check for the books. So we can say let's books equals what? Client dot what? Dot list book. So we can use this list books and then check. So we can assert that what? Instead of using assert, let's assert equal. Let's use assert equal. So you can say assert equal that the books dot length is what? Is 0. So can we see? Oh. So if we run this test by running cargo, let's just cargo fmt and format this first. Okay. Then let's use cargo run cargo tests. And by running this test, we can see that it's meant to pass. Can we see it pass? Now, how do we know that this is actually correct and this is passing? Now, let's look at a situation whereby we did not initialize. And then we go ahead. Now, I've commented line 12 by showing that we did not initialize. What then happens? Let's run this test again. It is passing. Why then is it passing? Can someone tell me why this test is passing even when we did not initialize? Can someone tell me why this test is passing even though we did not initialize? Anyone? I need comments on this. You can use the raise hand button, please. Are we saying we have no one that could think of why this test is passing even after we have commented the line that initializes it? Are we saying that? Okay, since we have nobody to answer, I would answer my own question. That is because of what we used here. That's because of what we used here. What we used here, we are calling the client.listbooks. Now, instead of client.listbooks, we did something. We created a scenario whereby if the library was empty, it should create a new what? A new instance of the library. Can you see? And this is why we have this unwrap or else. So imagine we used unwrap here and we just remove everything that was inside of here and we close it like this. What then would happen? Yeah. Let's run this test again. Can we see? Can we see the test actually failed? It failed. Why? Because it panicked. There was no initialization. But one thing we did, and this is more like basically the reason why I was making it clear for us to always try to avoid using the unwrap, because I tried using the unwrap and now, yeah, this is what we have. But because I have used the unwrap or else method, I already ensure that even if the library was empty, it should create a new, or it should return a new what? A new structure for a new empty library. So it's not going to panic, it's not going to fail, rather it will just return an empty library. And that is handling your errors well. And that's why you should be careful when you are using just what? Just unwrap. And so this has just helped us test what? The initialize. So even if we did not initialize anything and we are trying to list the book, it will just return 0. The next function we are going to test will definitely be the add book. So we are going to test the add book. So how are we going to test the art book? I mean, for the art book, if we add a book to the library and we count the amount of books in the library, should have increased, right? So that's what we're going to do. So we're going to do test art book, and for the test art book, what are we going to do? We're basically going to do the same thing we have done before. What's the same thing we have done before? These particular lines of code. We're going to first of all create the env, and it's just the environment where we would have opportunity to connect to the client, the host, and all of that. And then we're going to also create the contract ID. It's basically the same thing. Contracts ID. And then we're going to what? Do the same thing, register, and all of that, and do this. Now, due to the fact that we know we always have to do this, would it not be wise to make our code shorter and to make our code drier? Because I mean, a code base where you keep on repeating the same thing over and over, and that code base is not so dry. So to do that, we're going to just create a function, and we will name the function test setup. Inside of this test setup, we are going to return something. What are we going to return? We are meant to return this. So we're going to return this here, yeah, okay, good. And then we are going to copy everything here, X, and we are going to paste it here. So for this, we're going to remove this and this for it. And then we are good to go. Well, it's saying consider using static lifetime, but this is common unless you are trying to return. Okay, so for this, let's think of what we should do here. So let's try to just return client like this. Still going to complain about this static. So this is because we don't know the exact type we are returning here for this. So let's go back to the main library client and let's check. Let's check. Yeah, yeah. So why is it bringing us back here? So instead of all of this, you know what? Let's just return our library client here. And let's see. So why is it giving us more problem? This function returns types that contain a borrowed value. And that's what we are trying to do. Static like this. Okay, great. So what's the problem we were encountering? The problem we were encountering was basically we are trying to return um, a particular variable that could end or have a lifetime that is ended. But then we are trying to return it and we were not including the static and this lifetime signed to it. And so it was basically showing error. So we can basically remove this now instead of having to write some bunky as long um, lines of code. We can have this and this. So let's try to check it out for this. And instead of this, we can have this here now. So now imagine how many lines of code have been removed just for this. So easy. So we bring this like this, and then if we run this test, cargo test, good. So our initialize is still working perfectly the same way it's meant to work because we have added this test setup. So the next one we are going to work on is basically the add book. And so we are going to test it and we are going to use the method we have created for the initializer. We're going to name this client. And then we're just going to call the test setup. And what's the next thing we want to do? We want to basically initialize it. So since we know we have to initialize it, so inside of this setup, we can basically add what? Can basically add our initializer. So let's add our initializer here. So that means we have to initialize here. But if we initialize here, what then would we be returning? Would we be returning the result of this initialize? So no, let's not initialize. Let's not initialize. Or let's try it. Let's select client equals this, and then we say client dot initialize, and then we return client basically. This works, yeah, it works. Um, okay, we have to put the semicolon here. So this works perfectly, and it helps us eliminate the idea of calling this line again. So now all I'm doing is just trying to make our code very dry. I don't want us to repeat anything, and that's basically why I'm doing all of this. So let's test add book. So to test add book, we have initialized. Then the next thing we want to do is to say client dot add book. So what's the book we want to add? The book we want to add would be symbol short, and we could call it Rust book. Rust book. Let's just call it Rust. And then for the author, no, I'm not the author of Rust book. Let's use my name for now. So we'll just name it Ayo. And then the next thing we'll do is the year it was released. What year was it released? Let's say 2023 for it. And we are good. So what's the problem? Oh, we didn't add the reference sign here. Okay. And these two, we didn't include the reference sign. Okay. So the next thing we want to do here is we have added one book. And now, how are we even sure that the book we added is actually the correct book? That it means that we need to check how many books is here, right? So to check how many books is here, we can basically use our list books function. So we just select books equals what? Client dot what? Dot list books. And we know client dot list book is literally going to give us a vector of books. And what then is the next thing for us to do? We want to assert that what? The book is what? Is one. So we want to say assert that books dot length is what? Is one. Notice that we had not added book here, and that's exactly why when we checked if the book was added to the library, it was 0. But now we have added the book, and so definitely adding the book would mean that what? The book length has increased. Also, we could even use this count books function too. So we can even say assert equal that client dot count books is what? Is 1. So counting the books using this count book, because this function literally helps us count all the books in the library. So using this count book, we could use client dot count books equals 1. Now we have asserted it. We can run this code and do cargo test. And doing cargo tests would basically mean we have successfully run this code and you can see it's working correctly. Now imagine we said the book was 2 when the book we added is just 1. What then happens? We have a what? A failure. Can you see? It's saying the left is 1, right is 2. That is the book we added, it's meant to be 1 because what we are testing again is 1. Good. So we have 1. And this shows that our test is working perfectly. Now, let's try to add another book. So if we try to add another book, we can use, I think someone is mentioning something here. Okay, Celia mentioned she hasn't been added to the repo. So IJ, you can look into that. So we could say client.add book. And then this time, let's name our books. Let's name it what should we name it? Soroban. Let's name it Soroban. The author. Well, let's use IJ as the author of Soroban. So let's say IJ, and the year she released it. Let's say she released it about 1890. That's a very long time. How true is that? So now we've added another book to the library. Now, so we basically have to check if the book we added to the library is actually added to the library. So by now we know that the book we've added is now 2. So we can assert, so we can use assert equal clients dot count books is what? Is 2. So this time if we assert it, it's definitely, let's clear this. Cargo test. Exactly. Exactly. So this is correct. So test initialize and add book is basically running correctly. So the next function we will test is basically to remove books. So let's quickly come up with that test. So we can test to remove book. So let's write our test trait here and then add test remove book. Okay, to remove book, we can basically call our client by basically calling our setup. So we call test setup. It's a function, it's the upper function we created. And basically We have to basically add, let's try to add these two books that we added here. So let's add this one. So let's add this book. So at this point, we added this book. Let's also add this one. Pa, 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 pa. Let's add this one. Let's add about three books. So let's add this one again. This time, let's name this one Golang. Let's name it Golang. This time it's not by IJ. Let's say it's by Wisdom. And let's say this is about 1720. That's awfully long. So we've added about three books to our library. Obviously, we know we have three books in the library now. Then the next thing we want to do is basically to test if we can remove a book. So we're going to say client dot remove. This time, notice that the one we want to remove is Soroban. Let's remove Soroban. So to remove book, we want to remove the book by the title. So we are going to remove Soroban. We say symbol, short, and then we remove Soroban. And so, yeah. Then after removing Soroban, we can basically check how many books we have. We can check how many books we have. We can say assert equal. Let's use assert equal. Now, the books basically should be about three now. About two now. So we can use count books two. So if you run this cargo test, it should basically run successfully. Can we see? This means that this remove function actually works. At this particular point, before we called the remove function, if we actually asserted that the books were actually three, as you can see, we assert it that it was three and we run our test. Can you see the test is still passing? But because we have removed this, we are sure. Now, how do we even know that the book has actually been removed? We can write another test. We can say assert equal. We can say let's create the list of books. Let's create the list of books for what I want to do. Can say let's books equals client dot list books. So we want to list all the books. Then we want to say books dot get. This time we want to get index 0. No, let's get index 1. Index 1. Then we want to unwrap it. So we do dot unwrap. And then we do dot title. At this particular point, index 1 should be what? Index 1 should now be Golang, since we have removed Soroban. So index 1 should be Golang. So let's try it. So let's say symbol short Golang. Oh, why are we using the reference sign here? We don't need it. Okay, so now let's test it. Perfect. So this is how we come to the end of our class for today. And thank you very much, everyone. I hope everyone understood the test. Are there any questions? Wow. Yes. Okay. So
Hello.
Cynthia, yeah.
I wanted to ask, like, is the library like connected to like some kind of database?
It's just a library contract. It's you can think of it like we are implementing a library app. You can think of implementing a library app and we are implementing a smart contract for this library app. You get that, right?
Yeah.
So implementing that smart contract, we said our library app, we want it to be able to add book, remove book, find book, list book. And so for the smart contract, we actually implemented this and we were able to actually test it and see that it is working. So this is what our test is for. Dennis?
Mine is not a question, maybe a
Okay.
request.
Okay.
Please share the code with us so that we can review in the next class.
No problem. No problem. I would send the code. I'll share the code. Share the code.
Dennis, so that you know, I sent him a DM telling him to get the code on a gist. He didn't see it because he was in hospital. Let me let it slide because he was just sick. He was like running errands, but I sent the DM to him. And also Sila wants a study buddy from this place.
Okay. Okay, yeah. I think it's a great one to have a study body. I mean, you can even do implementations and hackathons together, even create organizations together, you know.
Yeah,
It's a great
that's why I have them in on the like teams in GitHub. You can reach out to your peers there.
Yeah.
But if you want me
Indeed.
like
Thank you so much for that. It's actually for my eyes. I'm losing my eyesight. I guess I look at the screen so much. I was trying to get to the optician to get for my eyesight. But thank you so much. Thank you so much. Thank you so much. Okay, if there are no more questions, I would stop sharing my screen and we would meet tomorrow. And there's a probability I'm going to send a question over for us to practice before tomorrow's class. So this will help us. It's going to be part of the questions that is in our curriculum. Because in our curriculum, we are meant to implement 5 smart contracts. But because I've not implemented a full smart contract, that's why I've not sent those questions. So I'm going to send the first one. If I don't send it, then during the class, I'm going to send it during the class tomorrow. But expect that within the next 5 days, that's including your weekend, you definitely have to implement some smart contracts. So enjoy the rest of the day, everyone, and goodbye.
yeah, they will share the code. Yes. Okay. Thank you so much, everyone. If you guys still need to be added on Telegram, not Telegram, on GitHub, let me know. But I think I've added everyone there. Yeah. So see you guys tomorrow. Thank you. Ntiro, I'm very sorry. I think you missed the timing, but see you tomorrow, same time, 4 p.m. EAT. Okay, so tomorrow it won't be this time. We'll go to the usual time. Okay. Okay, see you guys tomorrow. Bye. Julius, can you like